What we're going to talk about today are sedimentary rocks. You may remember from class on Thursday that sedimentary rocks are classified or grouped by how they're formed in three different ways. We have clastic, we have chemical, and we have organic groupings. Let's take a look first of all at clastic and what that means. So what clastic means is it's made up of particles from other rocks. Let's take a look at these over here on the left. This is gravel. The next one down is sand. And then this represents mud. So when those particles come together to form a sedimentary rock, that's called a clastic rock. Depending upon how many of the particles are in there and the particle sizes will begin to determine the name of the rock. In this particular case, this rock over here on the right is called conglomerate, but that's an example of a clastic rock. Other examples of clastic rocks are conglomerate, I just mentioned, that's this one right here. Sandstones down here. Notice when you see a sandstone, it often shows layers because the sand was deposited in layers. Sometimes those layers take on different coloring, so you might have different colors in the layers themselves. Another one is mudstone. And then really fine mud is called silt, and down here we have an example of siltstone. So those are the clastic sedimentary rocks. Another grouping of sedimentary rocks we have are chemical. That means that they were formed somehow with a chemical process. This picture up here in the upper left-hand corner is travertine. If you've been to Yellowstone Park and if you've seen Mammoth Hot Springs, that's travertine. Travertine is actually limestone originally. It was limestone originally. It started underground as limestone, and then hot water bubbled through that limestone and it dissolved the limestone, brought it back to the surface of the earth, dissolved in that hot water. And then it deposited, the water starts to flow out on the surface of the earth and it deposits that new material, now called travertine. As the water evaporates away, the travertine is left behind, and that is the chemical formation of a sedimentary rock. In that case, it's travertine. If you've been to the Lewis and Clark caverns, you probably have seen stalactites and stalagmites and stalactites. So down here we have stalagmites, and up here on the right-hand side we have stalactites. Those are also formed through a chemical process. Organic creation of sedimentary rock. Organic means that once upon a time was alive. So up in the upper left-hand corner here we have some coral. Eventually that coral will die. The material will settle down to the bottom of the ocean. It will be settled upon by more and more particles of organic material. More and more material gets deposited on top of that, and over time that can solidify with the pressure on top of it and create a sedimentary rock. Coal is formed that particular way. This diagram down here shows that coal started off as plant material. Right through here, that plant material decomposes, it falls to the ground. This usually happens in very moist places, oftentimes warm places. It forms a material that we call peat. And then as more and more material gets piled on top of that, a little bit of heat, not quite the same amount of heat that we had with metamorphic rocks, and a little bit of pressure, again, not quite the same amount as we had with metamorphic rocks, but similar to that, and eventually that heat and pressure change this plant material into coal. So that's how coal is created, and since it started off as plant material, that is an organic formation or organic sedimentary rock. However, some sedimentary rocks are actually a combination of both organic and chemical, so we call those biochemical. So they had something to do with life, bio for biology, and it was formed in a chemical process. One of those sedimentary rocks is limestone. So again, picture the ocean, and you've got lots of living materials, critters living in the ocean, and they die. And so the shells then fall to the bottom of the ocean, they get trapped in the sand, eventually more of that material gets put on top of it, more sand gets put on top of that. We have some pressure from above, from the water, from other materials, and eventually that it gets compacted and changed both from in a chemical process, and again, since it started with living material, at the biological process, and then we end up with limestone. One of the cool things about limestones is that they sometimes contain fossils. So even the samples that you looked at, there were a couple of, at least one of the limestone pieces that have fossil in it. Okay, so that's how sedimentary rocks are formed. Hopefully you took some notes on that. That'll help you as you begin to identify those rocks next week. Now let's take a look at the metamorphic rocks that you have been identifying the last couple of weeks in class, and let's go ahead and name them. So hopefully in your notebook you said that number one was quartzite. It started off as quartz, and then it got heated and pressured, and it became quartzite. Number two was marble. I don't think we did number three, so you shouldn't have that one. Number four is called gneiss. It's pronounced nice, not nice. And this is an example of the gneiss that you had from class. Notice the nice wide bands in there. And that was a pun intentionally, by the way. Nice wide bands indicates that that is a piece of, or that example is nice. The next one is a grouping that we call schist. And there's narrow bands with schist. Excuse me. And the other way that we identify schist is by the material that it's made up of. In this particular case, this is mica. So since there's mica that makes up the schist, this is called mica schist. Another example of a schist is garnet, and I of course can't get my fingers on it real quick, but here it is. Here's garnets embedded in the schist, so this is called a garnet schist. Number 7 was phyllite. Number 8 was slate. 9 is serpentine. 10 is graphite. It's the same graphite that you saw as a mineral, but it was formed in a metamorphic process, so we also classify it with metamorphic rocks. Number 11 is talc. Again, you saw that as a mineral. 12 is chlorite. 13 is biotite mica. Again, that was a mineral. 14 were garnets, which you also saw in number 6 in the garnet schist. And number 15 was kyanite. So make sure that you have those corrected in your notebooks. I will get a score from you in class on Thursday as to how many of those you got correct. And if you have outside of time and you want to do a little bit more research on sedimentary rocks before you finish up that identification on Thursday, that would be great. Otherwise, I'll see you in class next week.